The Sahara is a vast, desolate desert where water is as rare as a miracle. Yet, in this unforgiving heat, something extraordinary is happening. Solar-powered machines are defying the odds, pulling water from the very air of one of the driest places on Earth. But how are these machines creating life-sustaining water where none should exist? Stick with me, because what you're about to uncover may change the way you think about desert survival. And this could hold the key to solving water scarcity for billions worldwide. The Sahara Desert is not only the largest hot desert in the world, but it is also a relentless, endless stretch of sand and rock. Spanning over 9 million square kilometers, it covers much of North Africa and impacts the lives of more than 2.5 million people. And this desert is expanding at an alarming rate, encroaching further southward by about 48 kilometers every year. It's taking livelihoods with it, pushing entire populations into desperate circumstances. But here's the twist. Despite the Sahara's extreme aridity, it's not entirely lifeless. Approximately 44 million people still reside in the region, struggling to survive in one of the harshest climates on Earth. The reality is that this desert is constantly growing, and temperatures in the region are rising faster than anywhere else on Earth. Since the 1970s, the region has been grappling with severe droughts that decimate crops, livestock, and entire communities. This isn't just an environmental problem, it's a human one. With temperatures climbing and the Sahara creeping closer to populated areas, millions of people are facing forced migration, conflict, and the destruction of their agricultural base. Agriculture, once the backbone of these communities, is declining, taking with it a significant portion of household income and food security. The global implications of this are enormous. It's not just the Sahara that's shrinking. Across the world, deserts are expanding. More than 1 billion people, roughly 13% of the global population, already live in desert regions. Another billion people in over 100 countries are at risk of being affected by desertification, the process that turns once productive land into barren wastelands. Water scarcity, which affects 1.5 billion people globally, is a growing crisis that threatens to displace up to 700 million people by 2030. So, what's the solution to the water crisis in these arid lands? The answer might lie in an astonishing breakthrough. Enter Mali, a landlocked country in West Africa. Most of its vast territory lies within the southern edge of the Sahara Desert. 65% of Mali's land is desert or semi-arid. The country, despite being one of the largest in Africa, has a relatively small population, with the majority of its people living along the Niger River. This river is a lifeline. However, the region is no stranger to severe droughts, and the expanding desert is a constant threat to the stability of the people and the land. Mali faces a grim dilemma. Water scarcity is rapidly intensifying, and traditional sources are drying up. Droughts have forced farmers to abandon their lands, triggering waves of migration and even sparking conflicts as resources become scarce. In the middle of this struggle, a bold idea emerges. The Sun Glacier Project, a daring initiative with a singular vision to create water where none should exist. Led by Abvar Hagen, a Dutch sculptor, writer, and innovator, the project's goal is to use solar power to pull water from the air. Hagen, inspired by his time in the Arctic, witnessed firsthand the disastrous impacts of climate change. But instead of surrendering to despair, he sought a solution. He realized that while deserts are dry, they still hold water in the air, though it's not visible in the form of rain. The key to this breakthrough is solar power. But could this daring project truly work? The machines they envisioned would need to do something extraordinary: condense water from air that's nearly devoid of moisture. Could technology overcome the extreme dryness of the Sahara? Could the sun, which relentlessly scorches the land, actually provide the solution to one of the most pressing problems of climate change? And so, the project's first test was set in the heart of Mali, where the stakes were the highest. The moment the Sun Glacier machine was tested in Mali, something remarkable happened. What seemed like a wild dream, a machine capable of pulling water out of the desert air, actually worked. But it wasn't magic. It was science, harnessed most unexpectedly. The machine itself was surprisingly simple yet brilliant. Powered entirely by solar panels, it used the heat of the sun to cool a metal plate. When the temperature dropped low enough, the moisture in the air condensed against the plate, dripping down into a collector. It wasn't much at first, but it was water. Real, usable water. In the desert, it was the beginning of a new life. The technology, however, didn't come without its challenges. The team quickly realized that in the dry, scorching heat of the Sahara, the machine needed to be optimized constantly. The first models were slow and the water they produced was minimal, but that didn't stop the team. It became clear that scaling this technology could be a game changer for people living in arid regions. Over the next 12 years, the Sun Glacier team improved on the design. They refined the process of condensation, improved the efficiency of the solar panels, and made the machines cheaper and more durable. One of the most efficient versions, the DC-30 model, completely changed the game. It had no batteries, no inverter, and no complex moving parts to break down. It could be powered by a small solar panel, costing only a few dollars. This made it incredibly affordable and easy to scale. And then there was the Droplet 20, which could produce up to 30 liters of clean water per day. It was compact, mobile, and durable, perfect for remote areas where transportation was often a challenge. With its lightweight design and multiple power options, it could easily be transported and used in any off-grid location. This wasn't just theory, it was working in practice. In Mali, the first field tests had already shown that these machines could provide water for agricultural use and even clean drinking water. But beyond that, they could serve as life-saving devices in regions where water sources had completely dried up. In places like the Sahara, where water scarcity is a chronic issue, this technology could be the difference between life and death. Yet, despite the success, there were still obstacles. Scaling the project, spreading it to other countries, and making it affordable for widespread adoption were daunting challenges. But this wasn't just about Mali. It was about creating a model that could be applied to drought-prone regions worldwide. But as with any breakthrough, the question remained, could it scale? And here's where the true emotional weight of this technology comes into focus. Imagine a family living in a desert village. For years, they've struggled with water scarcity, walking miles just to gather a few liters. Now, with this solar-powered machine, they could have water whenever they need it. The despair, the fear, the hopelessness, it could all change in an instant. But change requires more than just good technology. It requires political will, global cooperation, and the resources to make it happen on a massive scale. Could the world truly embrace such a solution? Or would the status quo continue to leave billions stranded without access to the most basic human need? The story of Sun Glacier's solar-powered water machines doesn't just end with the innovation itself. In many ways, it's just the beginning. What we're witnessing here is a glimpse into the future. A future where humanity stops fighting against nature and begins working with it. The Sahara, once a symbol of desolation, could become the birthplace of a solution to one of the most critical crises of our time: water scarcity. We've seen the potential in Mali, a country on the front lines of desertification and drought. What started as a small-scale test now holds promise for communities across the world. People living in remote, arid regions where water is more valuable than gold. This technology, born from the harshest of environments, could soon change the lives of millions who have had to make do with little more than dry land beneath their feet. But here's the lingering question. Can this technology scale fast enough to meet the growing crisis? The clock is ticking. As climate change accelerates and deserts expand, more and more people are at risk of losing access to clean water. The Sun Glacier project provides a hopeful sign, an example of how innovation, driven by necessity, can offer solutions when the world seems to be running out of options. So, what happens when humans refuse to accept that nature's limits are unchangeable? We invent, we adapt, we create the impossible. And in doing so, we may have just stumbled upon a model for not only surviving climate change, but thriving through it. In the end, the Sahara could be the birthplace of the world's most sustainable water source. It raises an important moral question. How often do we look at challenges, no matter how vast, and simply accept them as barriers? What if, instead, we looked at them as opportunities, an invitation to innovate, to adapt, and to evolve? Perhaps the real lesson here is simple. The world's greatest challenges often spark the world's greatest innovations. And sometimes, the most extreme environments can hold the key to saving us all. And with that, we close the loop. The next time you look at a desert, remember, beneath the scorching heat and endless sand, there may be the seeds of something life-changing.